All right, so now we're going to look at evaluating powers that have rational exponents and rational bases. First example is something that looks like this, right? So you've got 27 to the 4 over 3. A trick that we'll use for a lot of these is to take the fraction here, and I'm going to split it apart into two fractions. Because just remember that when I multiply fractions together, say if I have a over b times c over d, I multiply my numerator by my numerator and my denominator by my denominator. Okay? So if I've got 4 over 3, then I can imagine for a second that I can write 4 over 3 as 1 over 3 times 4 over 1. Okay? You can confirm by multiplying this back. 1 times 4 gives me 4. 3 times 1 gives me 3. All right? So I'm actually going to split this single fraction into two fractions. So instead of writing 27 to the 4 over 3, I'm going to write 27 to the 1 over 3 to the 4 over 1, or just to the 4. Okay? So now, this piece right here, actually I can evaluate pretty nicely. Okay? And you might ask, well, could I just write this as 27 to the 4, then to the 1/3, so just switching these exponents around? I actually could. So I could write that just like this, and I would still end up with the same answer. The trick here is if I'm looking at which of these is easier to evaluate, well, 27 to the 1/3 is really just the cubed root of 27, which is a nice number. However, 27 to the 4, while that is possible to do, it is quite the large number. So I generally go with what's easier. In this case, evaluating this is a bit more difficult. However, 27 to the 1/3, as we mentioned, is really just equal to the cubed root of 27. So that it means what number multiplies by itself 3 times to give you 27? Well, we should notice that 27 is 3 times 3 times 3. So this is just equal to 3 here. Okay? Then, that simplifies this. Instead of having 27 to the 1/3 to the 4, I can now write this, because I know that this in here is just 3, as 3 to the 4. Okay? Now, to evaluate 3 to the 4, I would just multiply 3 by itself 4 times. So 3 times 3 times 3 times 3. An easier way to evaluate exponent 4 in your head is to square twice. So you can imagine for a second, if I take 3 and square it, I get 9. And if I square it again, I get 81. So 3 to the 4 is equal to 81. Okay? So that's the first example. Let's move on to a second one. So a second one, 0.04 to the 3 over 2. Okay? Anytime you've been given a decimal, I recommend converting it to a fraction, because it's actually easier to work with the fractions in this case. So 0.04, if I want to write that as a fraction, I just think about this for a second. That place value of that 4, well, this is the decimal point, this is my ones place, this is my tenths place, this is my hundredths place. So this tells me I've got 4 hundredths. Well, if I've got 4 hundredths, then that means I can write that as 4 hundredths, just like that. So 4 over 100. Okay? So if I take the thing that I started with and rewrite it as 4 over 100 to the 3 over 2, this is actually easier to evaluate. Okay? Because now what I can do, I've got a fraction raised to an exponent, so I can use the property where this exponent needs to be applied to the numerator and the denominator. So 4 over 100 to the 3 over 2 can be written as 4 to the 3 over 2 over 100 to the 3 over 2. Okay? And now I can evaluate these similarly to how I just did that first example. So I can do them separately, first of all. So 4 to the 3 over 2, I'll just do that off to the side. So 4 to the 3 over 2. I can split that apart, right? Because 3 over 2 can be written as 1 over 2 times 3 over 1. So I can write that as 4 to the 1 over 2 times 3, which is actually quite easy to evaluate here. This is 4 to the 1 over 2 is just the square root of 4. The square root of 4, of course, is 2. So I've got 2 cubed now. Well, 2 cubed is 2 times 2 times 2, which is 8. Okay, so my numerator here is actually just going to come out to 8. Okay, denominator, so 100 to the 3 over 2. So we'll take the same approach. So write that as 100 to the 1/2 to the 3. Okay, 100 to the 1/2 is just the square root of 100. And then the square root of 100 is 10. So this is just 10 cubed, which is 1,000. Okay, so I can write this as 1,000. All right, I can actually now notice that this fraction is reducible because both of those numbers are divisible by 8. So if I divide 8 by 8, I get 1, and if I divide 1,000 by 8, I get 125. So the final answer here would be 1 over 125. Okay. Next one. So how about if we have negative 32 to the 0.4? Again, anytime you're given a decimal, it's easier to write it in fraction form. Okay, so 0.4, well, that 4 is in the tenths place, so I could write this as 4/10. This fraction can then reduce actually to 2 over 5. Okay, so I can rewrite negative 32 to the 0.4 as negative 32 to the 2 over 5. Okay, well, now I can split this apart again, because 2 over 5 can be written as 1 over 5 times 2 over 1. Okay, so this can be written as negative 32 to the 1 over 5. I guess I should technically put the bracket around there, to the 2. Okay, so this would be, in this case, negative 32 to the 1 over 5 is really just the 5th root of negative 32 to the 2. Well, one thing that we should keep in mind is that 2 to the 5 is equal to 32. Okay, so that tells me that the 5th root of 32 would be 2. So the 5th root of negative 32 could be negative 2. And I'm going to square it. Well, negative 2 squared is negative 2 times negative 2, which is a positive 4. Okay, so now let's move on to one last one here now. So we'll bump it up a little bit. So we've got 16 over 9 to the 3 over 2. So now to evaluate this, what I can do is apply this exponent to the numerator and to the denominator. So this could be written as 16 to the 3 over 2 over 9 to the 3 over 2. And then I evaluate them separately. So 16 to the 3 over 2 can be written as 16 to the 1 over 2 cubed. 16 to the 1 over 2 is just the square root of 16, and then I'm going to cube it. So 16 square root is 4 cubed, which gives me 4 times 4 is 16, and then 16 times 4 gives me 64. 9 to the 3 over 2 now, because my numerator here is now 64. 9 to the 3 over 2 off to the side again. So I could split that into 9 to the 1 over 2 cubed. Well, 9 to the 1 over 2 is just the square root of 9. Square root of 9, of course, is 3. 3 cubed is 27. So this then gives me 64 over 27. And I don't think that fraction can reduce.